Hello guys, welcome to my channel. Please, after watching this video on proof by mathematical induction, please don't forget to subscribe if you like, comment and share. Alright, we are given this question, you know to prove. Before you start watching this video, just subscribe if you like and comment. We are given this question, proof by induction that the summation of upper limit a and lower limit r is equal to 1 should be equal to 1 over r open bracket r plus 1 should be equal to n over n plus 1, and 6 marks is awarded for that question. This is situation number 2 on proof by mathematical induction by proving of summations by mathematical induction. Moving on to situation number 2, we want to see how to prove this summations. Situation number 2 by mathematical induction. What we are going to do is we are going to follow the 3 steps we used to follow. We have the first step, assume true for n is equals to 1, assume true for n is equals to k, assume true for n is equals to k plus 1, then move on to the proof stage. But just note that whenever you assume true for n is equals to 1, but the left hand side is not equal to right hand side, meaning that it is not true for n is equals to 1, which means we have to move on to assuming true for n is equals to 2. When 2 denied, when left hand side is not right equal to right hand side, left hand side is not equal to right hand side, whenever I assume true for n is equals to 1, meaning that we have to move on to assuming true for n is equals to 2. When 2 denied, moving on to assuming true for n is equals to 3. When 3 denied, moving on to assuming true for n is equals to 4, until you get the value where the left hand side is equals to right hand side. But also note that some questions, they will give you the boundary, or they will give you the domain. You may be given proof by mathematical induction, then you will be given a certain question, but n is greater than 1, meaning that we have to start assuming true for n is equals to 2. Since it's greater than 1, meaning that the value which is greater than 1 is 2 and above. So we have to neglect 1, then start assuming true for n is equals to 2 whenever you are given the domain. Just follow the steps you were asked to do, right? Moving on to the solution, we want to prove summation of upper limit r is equals to 1, upper limit n 1 over r open bracket r plus 1 should be equal to n over n plus 1, which is 6 marks is awarded. So let's move on to the first stage. For n is equals to 1. We want to assume true for n is equals to 1. Assuming true for n is equals to 1, so we are saying left hand side, then also right hand side. So let's take this left hand side is here. So we have, but remember n is equals to 1. So left hand side we don't have n, but we have r. So we have to let that n r be 1. So we are saying 1 over, but r is 1. So we are saying 1 plus 1. So 1 is multiplying 1 plus 1. Then right hand side we have n over n plus 1. So it simply means 1 over 1 plus 1. Here we go 1 over 1 plus 1, which is 2. 2 times 1, which is 2. Then 1 over 1 plus 1, which is 2. So left hand side is equals to right hand side, as you see. So meaning that true for n is equals to 1. So true for n is equals to 1, which is true, as we notice together. True for n is equals to 1. Let's now moving on to assuming true for n is equals to k. So assume true for n is equals to k. But whenever we want to assume true for n is equals to k, we want to use this side. So we are saying the summation of upper limit k, lower limit r is equals to 1. We have 1 over r open bracket r plus 1 should be equal to, but n is equals to k. So we are saying n over k plus 1. We are done with proving. By proving, we assume true for n is equals to, so it's an assumption. We assume true for n is equals to k. We are done. Let's move on. Assuming true for n is equals to k plus 1. So assuming true for n is equals to k plus 1. So we are saying assume true for n is equals to k plus 1. So we want to assume true for n is equals to k plus 1. So we can use this side. All right, let me finish here. Assuming true for n is equals to k plus 1. So we are saying we are substituting here. So we are substituting. So this should be equal to, remember, n is equal to k plus 1. So k plus 1 over, right, assuming true for n is equals to k plus 1. K plus 1 is 1 over r open bracket r plus 1 should be equal to k plus 1 over what? Over k plus 1. Remember, r is k plus 1. I mean, n is k plus 1. So k plus 1 plus 1, it becomes k plus 2. We are saying n is equals to, here n is equals to k plus 1. So it becomes 1, or it becomes k plus 1 over what? Over k plus 1 for n plus another one given. So this one becomes 2. So, right. So now we assume true for n is equals to 1, n is equals to k, and also n is equals to k plus 1. Let's move on to the proof stage. We want to move on to the proof stage. Let me use this side for the proof stage. Right. Let's move on to the proof stage. Proof. We want to prove. So what we're going to do whenever we want to prove, remember we are on summations, so we have to add the k plus 1 the term to the right hand side. So what we are taking is, we are taking this expression, we assume true for is equals to k. So we are taking this expression, so we are saying this is equals to k over k plus 1 plus k plus 1 the term. Right, we are adding k plus 1 the term, right? K plus 1 the term. So where to get k plus 1 the term? We are going to use this expression here to find k plus 1 the term. So we are saying, remember, k plus 1 the term, each and every value of r is k plus 1. So we are saying this is equals to k over k plus 1 plus, right, k plus 1, we have 1 over, but r is k plus 1. So we are saying k plus 1. Then r plus 1, but r is equals to k plus 1. So if k plus 1 plus 1, it becomes k plus 2. K plus 2. So here we go, now we are on this stage. So what we have to do is k plus 1, k over k plus 1 plus 1 over k plus 1, k plus 2. You have to find the lowest common denominator, right? Finding the lowest common denominator, we have k plus 1, k plus 2. This is your lowest common denominator, right? So k plus 1 into k plus 1, k plus 2. You left with the k plus 2. So k on the numerator is multiplying what you got, k plus 2. Then k plus 1, k plus 1, k plus 1, k plus 2 into k plus 1, k plus 2 is 1. It's 1. 1 times 1, which is 1. Then let's now simplify the numerator. Then now we have k squared plus 2k plus 1 all over k plus 1, k plus 2. So now we want to finish our question, right? So now we have k squared plus 2k plus 1 all over k plus 1, k plus 2. So what we have to do on this stage, now we are on this stage, we have to factorize the numerator. We want to factorize the numerator. We have k squared plus 2k plus 1. But remember, the coefficient of k squared is 1. Applying the ordinary level general mathematics application. So remember, the coefficient of k squared is 1. So meaning that your factors are your solutions. Your factors are your solutions. So want to find the factors of what? Want to find the factors of plus k squared. If we multiply those two factors, it's like you want to find the factors of 1. If you multiply those two factors, 1 times 1, they'll give you 1. But if you add them, they'll give us 2. So which is 1 and 1. So meaning that since the coefficient of k squared is 1, meaning that k here, so it becomes k plus 1, k plus 1. So this simple way of factorizing this is just an application on what you did on general mathematics. So this is equals to k plus 1, k plus 1, all over denominator k plus 1, k plus 2. But k plus 1 can cancel k plus 1, and you left with k plus 1 all over k plus 2. But if you need to have k plus 1, k plus 2, which is similar to, when you assume true for n is equals to k plus 1, which is similar to this stage. So since this stage is equal to this stage, hence true for all positive integral values of n. So from this stage you have to write conclusion, since which is equal to right hand side. Can you say which is equal to right hand side? So conclusion, remember, don't forget to write the conclusion whenever you are proving by mathematical induction. Just because from this given 6 marks, conclusion can hold at least 1 mark. You can be given 1 mark on conclusion or even 2 marks on conclusion. So don't forget to write the conclusion. So since true for n is equals to 1, n is equals to k, n is equals to k plus 1, hence true for what? Hence true for all positive integral values of n. Hence true for all integral values, integral positive values of n. Why you say n? From r is equals to 1 up to n. So this is how to prove summations using section number 2. Prove summations by mathematical induction using section number 2. Please guys, after watching this proving of summations by mathematical induction, please don't forget to subscribe. Thank you so much.